NASA's Artemis II launch mission countdown begins, marking a pivotal moment in human spaceflight as the agency prepares the first crewed mission beyond low Earth orbit since Apollo. Today, teams at Kennedy Space Center initiate final pre-launch operations, reviewing systems, verifying trajectories, and confirming life support for the crew bound for lunar vicinity. Artemis II follows Artemis I's uncrewed demonstration, leveraging lessons learned to validate Orion, Space Launch System, and ground systems for crewed deep space missions. The mission will carry a crew on a multi-day lunar flyby to test human performance, navigation, and communications beyond low Earth orbit under real flight conditions.
This countdown is a choreography of engineering, timing, and human judgment, where every check and milestone must align for a safe, successful liftoff. Over the next hours, watch crews coordinate fueling, avionics checks, and final simulations as mission control tracks readiness down to the second.
Technicians perform propellant loading rehearsals and cryogenic conditioning, ensuring the core stage and upper stage meet strict temperature and pressure parameters. Engineers execute redundant systems verifications on guidance, telemetry, and abort systems, designed to protect the crew in every contingency. Flight surgeons complete medical evaluations and briefings, confirming crew fitness for the stresses of translunar injection and re-entry into Earth's atmosphere. The mission timeline is plotted in mission control, synchronizing orbiting mechanics, communication windows, and ground assets across global tracking networks. Safety officers inspect the launch pad infrastructure, ensuring ground support equipment, lightning protection, and emergency response teams are fully prepared. As the clock counts down, final software uploads and integrity checks conclude, locking the flight software for terminal countdown operations. At T-8 hours, the formal countdown sequence begins, transitioning the vehicle to launch configuration and enabling automated checkout routines. Mission audio and telemetry streams shift into active monitors, with engineers listening for anomalies in vibration, pressure, and power throughout the vehicle. On-screen countdown graphics update key milestones: propellant pressurization, main engine chill, ordnance arming, and terminal hold points before liftoff. Public affairs teams prepare to narrate the event, translating complex procedures into clear milestones for audiences worldwide watching this historic mission. Weather officers continually assess conditions across the launch corridor, tracking winds, cloud ceilings, and range safety constraints that could affect the launch window. Contingency checklists remain ready, and leadership maintains go-no-go polls to ensure every subsystem and support team affirms mission readiness. With minutes remaining, tanks reach flight pressures, and avionics cross-checks confirm timing signals for stage separation and engine throttling commands. Crew members complete final suit integrity checks, secure themselves aboard Orion, and run through departure procedures with calm focus and precise timing. At T-2 minutes, ground transmitters begin final synchronization and solid rocket power conditioning, marking entry to terminal countdown. The launch director conducts the final go-no-go poll, and mission control announces key system statuses as the global audience counts down with the team. In the last 60 seconds, automated sequences take control. The vehicle transitions to internal power and guidance assumes active flight control. Zero approaches, and the nation holds its breath as engines ignite, clamps release, and the spacecraft begins its ascent toward the unknown. Liftoff. The rocket departs the pad on a pillar of flame and sound, accelerating through the dense lower atmosphere toward orbital insertion. Stages separate and engines throttle as planned, with telemetry confirming velocity, altitude, and trajectory as Orion climbs into an initial elliptical orbit. Soon, translunar injection burns will propel the spacecraft out of Earth orbit toward a lunar flyby that will test systems under deep space conditions. Mission teams watch telemetry and crew health, ready to respond to anomalies, while the spacecraft begins its journey to extend humanity's reach. This mission is a stepping stone towards sustained lunar exploration, science, and the eventual goal of human missions to Mars. As Artemis II begins its voyage, the world witnesses a coordinated achievement of engineering, courage, and vision for the next era of space exploration.